Hello everyone, this is Daksh Joshi speaking from Vadodara, Gujarat, and I am going to present my communication skills assignment. Resting 5,900 feet below the ocean's surface, submerged in a seemingly lifeless and stagnant grave, lies one of the ghost ships of the Black Sea. This wooden ship has rested undisturbed for 2,400 years, frozen in time. After being viewed by a remotely operated vehicle's camera, a small piece of ship was raised and radiocarbon dated to the 5th century BC. Immune to the ravages of the time, this bit of history is like a fossil is suspended animation, preserved in a watery time capsule in the absence of oxygen. The Black Sea's unique geography and hydrological characteristics prevent the exchange of water from the surface to the deep. The sea is stratified, and below a depth of 600 feet, the waters are anoxic. Natural oxygen exchange between the atmosphere and the ocean keeps the upper layer of water in the Black Sea refreshed with oxygen. But the 90% of the Black Sea below the 600-foot mark is cut off from its only source of oxygen, making it a dead zone. However, the Black Sea is not alone. Other anoxic dead zones exist around the planet. The and geological history contains many examples of ancient seas where life was driven out as oxygen disappeared. Oxygen is a sine qua non for most of the life. Without oxygen, most life in land and in ocean perishes. The remains of ancient ocean dead zones exist in a geological record as black shales. What are black shales? Black shales are fine grained sedimentary rocks containing a high percentage of organic matter. The organic matter is fixed with the clay and slate particles. These rocks originate from sediments deposited in anoxic waters away from the currents and surface disturbances. The deposits then build layer upon layer over thousands to millions of years. But what makes them distinct from regular shales is the high level of organic matter. Normally, organic material like the remains of dead plants and animals falls to the ocean floor where bacteria and other animals consume it. However, when the deep ocean water is anoxic, very few organisms can survive there. And the bacteria that would normally eat organic carbon are gone. In this environment, organic carbon settles in with the slate and clay and becomes incorporated in the sediments. When the sea bottom mud is buried and turned into rock, the high organic content gives resulting shales a dark blackish color. The oil industry explores for black shales buried deep in the earth because as temperature rises, the organic material in the shale transforms into oil and gas deposits. A worldwide abundance of black shales at a specific times in the geological record indicates widespread anoxia in the world's paleoceans. During the late Cretaceous period, the atmosphere was rich in carbon based greenhouse gases, leading to a warm planet. But there were also large anoxic stretches of deep ocean collecting carbon and creating black shales. The resulting Cretaceous black shales provide a carbon store which removed some of the CO2 from the Cretaceous environment and fixed the carbon in the ocean bottom sediments. Today, black shales from the Cretaceous are a significant source of oil in our modern society. In a twist of irony, we are now burning ancient carbon and releasing Cretaceous greenhouse gases back into the atmosphere. So, an ancient hot world is helping humans propel themselves into another warm climatic conditions. Are dead zones really dead? Referring to the anoxic waters as dead zone is a bit of misrepresentation. Creatures do live in this environment, just not the type of life was usually except in the ocean. You won't find fish, scallops, or corals, nor will you find the carbon-eating bacteria, which normally feast on rotting wood and destroy the remains of any shipwreck. But there is still life in this water, different